All right, let's do the question next permutation. This is a medium Leetcode. So let's see what's going on here. A permutation of an array of integers is an arrangement of its members into a sequence or linear order. For example, 1, 2, 3. The following are all permutations. Okay, well, array 1, 2, 3, 1, 3, 2. Okay, so it's all the different ways you can arrange it, I guess, combinations and permutations. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. Okay. More formally, if all the permutations of the array are sorted in one container according to their lexicographical order, then the next permutation of that array is the permutation that follows it in the sorted container. If such arrangement is not possible, the array must be rearranged as the lowest order possible. For example, the next permutation of ARR, so array 1, 2, 3 is 1, 3, 2. Similarly, the next permutation of 2, 3, 1 is 3, 1, 2. While the next permutation of 3, 2, 1 is 1, 2, 3. Because it does not have a lexicographical larger rearrangement. Given an array of integers nums, find the next permutation. Array, the replacement must be in place. Can only use constant extra memory. So example 1 is 1, 2, 3 becomes 1, 3, 2. 3, 2, 1 becomes 1, 2, 3. Constant memory means that the memory can't scale with the input, which means that over in time, over in space, over in memory, constant memory is O of 1, so it should be a pointer or something like that. 1, 2, 3, 1, 3, 2. I'm not gonna lie, like all this would look like to me is if you had 1, 2, 3, you just swap whatever is there originally. One, two, three. Thing is, like, I could just swap, so I'm not sure how the output would be 1, 3, 2, constant extra memory. For example, 1, 2, 3 is 1, 3, 2, 2, 3, 1 is 3, 2, 1, 3, 1, 2. Given an array of integers nums, find the next permutation of nums. One sec, let me turn on the light too. What an interesting turn of events. The next permutation of an array of integers is the next lexicographically greater permutation of its integer. Uh, 2, 3, 1 has nothing greater than it. So it's got to be 1, 3, 2. So for example, when it says lexicographically greater, it's like going through a dictionary and looking for the word, right? So if you have the word bottle, no, yeah, bat and bottle, right? So bat and bottle. So let's say Lexicographically, if we think about this, there's bat and bottle, right? Lexicographically means this portion is the same. So we reference letter B if we want to find both these words, right? But lexicographically greater means that this is A, which means that if I want to also get something lexicographically greater, I have to get a letter after A, so O. So this satisfies the condition of lexicographically greater because O comes after A, but it's referencing the same letter. You see? So now we'll apply this logic to numbers and see if we can intuitively solve it on the whiteboard. And if we can do it on the whiteboard, we can do it in as it normally is, whatever the fuck. So for example, 1, 2, 3, right? This is what it means by lexicographically. We do the same thing we did with the words with this array of numbers. So 1, 2, 3. What's lexicographically after that, right? So what's the next permutation of this, right? So we want to keep 1. So since there's only 2 numbers, the only other permutation could be 1, 3, 2. Boom. Right? So the next thing, if we look at the next example, is 3, 2, 1, right? So 3, 2, 1. There's nothing greater than this combo. Because if I put 3, 1, 2, the 2, 1 is actually greater if we go by numbers, right? So if we go 3, 1, 2, this would actually be before this. Because this is lexicographically smaller, right? Because 1 is the reference point, 3 is the reference point, right? So then we would go 3 is the reference point, now 2, and then 1, right? So that means if we're at the biggest item here, there's nothing greater, then we have to go to the smallest. So now we go back to the start, 1, 2, 3. Then 1, 3, 2. Right? And lexicographically, the next item would be 2, right? So 2 is bigger than 1, because right now we're referencing 1. Now we have to reference 2. So 2, 1, 3, and then 2, 3, 1. That's bigger. And the only thing bigger than 2, 3, 1, because 3 is the biggest second index. If we swap the 1, it's not going to be bigger. The next one is to make 3 the index. 3, 1, 2, and then finally 3, 2, 1. And then it goes into this cycle over and over and over and over. So maybe that clears it up. That's my understanding of this question. Let me just control A it. But that's my understanding of this question overall. Like, that's where we ought to be with this. Now it's time to think about the logic for how I would go about turning this into code. Okay, so next is, I have my nums array. So let's take, for example, 1, 2, 3. How would I turn this into 1, 3, 2? So let's say I have a pointer at 1. Call P1. And then let's go P2. I would have to make a pointer for each one. That's the only thing that's kind of, because right now numbers length could be between 1 and 100, right, which is pretty fucking large, right? So and the number's length could be 1, right? So I can't make multiple pointers. So what I would do to check if it's lexicographically greater would be 2 pointers. Let's even do it, yeah, let's do it this way. So 2 pointers, and then let's go, if pointer 2 is greater than pointer 1, move both. Boom. So this goes here, and then this becomes this. Actually, for illustrative purposes, let me just do this. I'm thinking of this. So we keep going to these 2 pointers to find out where exactly it's lexicographically inconsistent. And if it is consistent all the way to the end, then we just flip the last 2 elements to make it lexicographically different. Okay, so yeah, so I'll start with 1, 2, 3. And if the number here is greater than the number here, keep going. Number here is greater than the number here, then I swap. So 1, 2, 3. So this is greater than this. So now my pointer 2 is here. And then this is greater, this moves with this. So now this is greater than this, but there's nothing left. Right, so now we can swap to get 1, 3, 2. Right, I think that's it. So let's try to code it out. I don't know, it's kind of confusing, but we'll try. It gave us the hint that we have to be sorted in place, which means we can't create a new array. And given an array of numbers, find the permutation. Find the next permutation. I know why my voice is all weird. It's because I just ate this like corn, and it's like weird. I don't know. I ate corn and beef and whatever the fuck. But yeah, that's the thing. Let's give it a shot. So let's start with P. So let's start by, let's figure out what we can finish, right? So the number's length could be between here. So it could be just an array of one element like this. If so, you just end off here. There's no permutation. If nums return nums. That's it. P1 equals nums zero, P2 P1 equals num 0, P2 equals nums 1. So that would signify what's here, what I'm doing here. So the next thing I want to do is I want to figure out how to move these in a way that it would satisfy the condition of next permutation. So if, or I could just go 4. I'm just thinking. I can only use constant memory, so I have to figure out the last point at which it's greater, and if nothing is greater, so for example, if I had 3, 2, 1, and I go 1, 2, this is smaller, this is smaller, this is smaller, then I would swap the last element with the first element. Let's try. So while well, this would be 0 and 1. This would be 0. This would be 1. While p2 is less than the length of nums minus 1. While p2 is less than the length of nums minus 1, which is correct, which means once we get to the last element, that's when we have to make a decision on what we got to do. So if nums p2 is greater than, if nums p2 plus 1 is greater than nums at p2 so you keep going, I guess. You keep going. So 2, 3, 4. Yeah, until it's not. So then it'll be p2 plus equals 1. So the number, if the next number is greater than the current number for p2, then go to the next one, then go to the next one, then go to the next one. If it gets to the very end, all right, so let's say let's perform the logic on an item just enough that it's bigger. You have to keep going back to the whiteboard, because if you can't do it conceptually, there's no point in doing it at all. So let's go 1, 2, 3, 4. Let's test our logic. P1, 1, 2, 3, 4, P2. So 3 is greater than 2. Okay, boom. 4 is greater than 3. Boom. Right. So now we're at 1, 2, 3, 4. P2. We got P1. We got P2 and P1. So now that we have 4, the next thing I want to do, if everything is greater, right, that means it's in order. That means it's at the minimum lexicographical thing. if it gets to the very end. So now we got to know what we could sub. If everything is greater, then we go P2 minus this, and then P1 plus this, and we swap. Because right now it's at 2. So it would be 1, 3, 2, 4. And then the next one would be 1, 3, 4, 2. You see what I mean? Because this would be lexicographically bigger than this, and this is lexicographically bigger than this. So this is already the max. So what we got to do is swap the indexes in the middle. So we need something to tell us that along this line, nothing was. Let's create a true false. So this is going to keep accruing value till the end. If greater equals true all around, greater equals false. So this is just purely going to keep track, because all I want to do is figure out where I want to put the first pointer, but the second pointer is going to go all the way down to make sure where we find a discrepancy. And let's create a P3 equals none, just in case. So else greater equals false, P3 equals P2 plus 1, right? So now we have the point at which it's not greater. So right now, we go all the way to the end. It's greater, greater, greater. Now it's at 4. How much time do I have, by the way? 23 minutes. Okay, we'll give it a few more minutes, then we'll see if there's a faster way to do it, but let's try to do it till 30. Let's go. So 1, 2, 3, 4. If we get to 4, then I want to reduce 1 for P2 and plus 1 for P3. So if greater, so if that's true, I want plus equals 1, P2 minus equals 1, and then that'll be nums P1, nums P1, nums P2 equals nums p2 nums p1. That's how you swap two numbers. After we increment the first one and decrement the second one, now we swap them, and then we return the array nums. Let's try it. At least do the first test case, should work. Time limit exceeded. Okay, so let's add a break statement here so it doesn't go on forever. What's the output? I just want to see. So 1, 2, 3 output. Expected 1, 3, 2. Interesting. Okay, so this should be p2 plus 1, p3 equals that. And this is if it's greater all the way down. Let's change the lexicography of this. Let's see if that works. I'm just curious. There we go. You see? 3, 2, 1. But for the first one, it goes 1, 2, 3. So it goes to the very end. I just add one switch, swap. I said switch and swap at the same time. I don't know why I did that. And then if you look at the last one, it works as well. Because if you go 1, 1, 5, swap. Because it follows the condition. The second one is 3, 2, 1. So when we get to a condition where you're at the last one, if, okay, if greater is true, then you go through, or if less is true, let's turn this into the if statement. Let's turn that into the if statement and break. In any condition, do this. So the P2 is always iterating. Then I want to adjust it for less. So I have one that's greater than, and I want to have one that's lesser. Equals true. And if lesser is true all the way to the end, like we might not even need the P3, is what I'm thinking. So else, if the next item is thing, so that means else lesser So if it's not greater, increment. Okay, if it's not lesser, so if yeah, it would just be else. So if it's else, then lesser equals false. Yeah, so whatever is false, basically. And then you break. Wherever you get a false, you break. Actually, for now, let's just leave that because it's not doing anything. And then if lesser, then you just want to swap the first and the last element without incrementing at all. Because that means if it's lesser all the way throughout, then you have to lexicographically go back to the beginning. Because that means it's decreasing all the way down, right? If it's increasing all the way up, then you just have to increment your lexicon. That's lexicographical. If it's lesser all the way down, that means you've sorted it to the highest degree. You can sort it in reverse. So it's like 1, 2, 3. Now it's 3, 2, 1, which means there's nothing bigger than this combo. Now we have to go back to the beginning. 1, 2, 3. So it's going to be if lesser. And I just copy this. I could just make a swap function as a helper, but since I don't repeat it many times, it's just this. That should pass all the test cases. Wait, what? Less is not defined. Lesser, less. Oh wait, I gotta get rid of this. Oh my gosh. One, 3, 2, 1, 2, 3. Just gotta delete this, go back to here. How much time do I have? Okay, I'm at 33 minutes. Okay, so now let's just go and try and solve it. Right now, this was what got us to 2 out of the 3 test cases. Alright, so let's put this in the chat GPT, but you guys get the gist of it. Chat GPT. If I had more time, I could do it, but I want to get used to doing these in 30 minutes. Otherwise, there's no point. If you can't do it in 30, like, because half the shit's gonna be timed anyways. This is my code. Involves reversing the array sections to find your current approach doesn't quite handle all the cases. Your more common approach to solve this problem. So identify the first decreasing element from the end. Traverse the array from the end and find the first pair where nums I is less than nums I plus 1. let this index be I. Find the largest element from the end of the array. Find the largest element from the end of the array that is larger than nums I, swap them. Reverse the elements from I plus 1 to after the swap. Reverse the elements from the index I plus 1 to the end of the array to get the smallest lexicographical permutation of that section. Okay, so I is len nums minus 2. Okay. And then while I is greater than 0, so it's going backwards, and nums I is greater than nums I plus 1, I minus 1. So if it's greater, move back. Greater, move back. So basically, if we have 1, 2, 3, if I is greater than 0, J is len nums minus 1. Oh, okay, so you're trying to find out where exactly you want to keep going. Find the first decreasing element from the end. Okay, so if it's 1, 2, 3, or 1, 2, 3, 4, this would be 3 right now. This is I, because it's minus 2. Len nums minus 2. And then I plus 1. So find the first decreasing element. So it says I is greater than 0, so it's greater than the start of the array. Then y and nums I is greater than nums I plus 1. Greater than or equal to nums I plus 1. So in this case, it's not, right? So 1, 2, 3, 4. So that would be 1, 2, 4, 3. That makes sense. So instead of going this way, we were actually just working backwards. That's the main difference between what we did. If we found such an element, find the element to swap with. So if I is greater than 0, equals j len nums minus 1, while nums j is less than or equal to nums I, j minus 1. While nums j is less than or equal to nums I. So we have to find the first element greater. Right, in this case, it already satisfies the condition because it's already greater. Right, so we don't minus anything from j, we just swap it as is. That's how you get 1, 2, 4, 3. And it says left and right. So left is I plus 1. Right is reverse the elements to the end of the array. So while left is less than right, while left is greater than right. So in this case, I would stay where it is, and len nums minus 1 would be 4. Oh, I plus 1. I plus 1's already 4. And then len nums minus 1, so it doesn't move anything if it's at the last. So if we're already here and we swap, I plus 1 is 3, and then len nums minus 1, so we swap itself with itself, so nothing moves. This is the final product. So that's in a nutshell how to solve it. So yeah, we'll give it a shot. So they said first let, I is equal to the length of the numbers array minus 2, because we want to go this and the next one and then keep figuring out where's the first discrepancy. Identify the first decreasing element from the end. So yeah, it's already decreasing. So while I is not, so we don't want it to overflow after the beginning element. So while I is less than 0, because this is an index, array can only go down to 0 index, can't go to -1, because array starts at 0. So instead of going from like 1 to 10, right, in an array it goes from 0 to 9. Alright, inclusive. So this and so while this I minus equals 1, so that's pretty much saying shift, 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 shift. That's what it wants us to do. We want to shift, and then the next step would be find the next largest element within the array. So this one's for j, so while I is greater than 0. So first we have to find the first decreasing element, then we have to find what to swap it with. So while I is less than 0, j equals len nums minus 1, because we want to start at the very top. And then if, oh no, it's going to be a while. This is the if. So if I is greater than 0, we have to figure out what to swap. And we run the while loop, so while nums j is less than or equal to nums I, keep going. So right now it's greater than, so we don't move it. But if it was 1, 2, 2, so if it was 1, 2, 4, 3, 2, this would be like, okay, nums j is less than or equal to, so then we go down 1, so it'd be j minus equal to 1 until we find something swap worthy, and then swap those elements. And then left to right is basically reverse all the elements to the end. Okay, cool. From I plus 1 to the end. I plus 1 could be the last element to the end. So if it's already the last element, nothing swaps, basically is what it's saying. So to the beginning would be going back to 0. You know what I'm saying? So left. So this is I plus 1. Because we already made the swap, so it's not going to look from here to the end. While left is less than right, if it's already less than right, then you don't even activate it. It just goes straight to nums. So you take whatever values here and you just go straight there. Otherwise you swap, then shrink, swap, same shit. So basically you just go here. And instead of I, this was going to be left, right, left. And this shit will come over time. So this is going to be L plus equals 1, so left. Right minus equals 1, boom. And you just keep shrinking towards the center. That should solve it. While left is less right. Oh, we need a colon here. Oh my gosh. Let it sit for 5 seconds. And then it says 2. Why is that not working? Okay, cool. Oh wait, Control Z, Control A, Control C. So now that you understand it, let's figure out where a couple of issues with the code. Show me only the lines I need to fix. While I is less than 0, I is less than 1, 2. Oh, while I is greater than 0. Yeah. Because I has to be greater than 0 because it's 0 index. It can't be less than 0. Because if you go less than 0, you're going to overflow past the array. Right? And we don't want that. The beginning is 0. So we can't go beneath 0 and to negative 1. Right? So let's run that. It's always some syntactical thing. And then greater than nums I plus 1, and then change this line. While I is greater than 0. Greater than or equal to 0, okay. Interesting. Greater than or equal to 0, and then I got nums I plus 1. Greater than or equal to. Do I have greater than or equal to? And then nums I plus 1. Small typo in the last swapping loop. What did I do wrong this time? Why? Right, left, left, right, right, left. Did I not do that? What did I do here? Left, right, left, right. Oh my gosh. This always happens, bro. Always, always, always. But the idea was with pure intent. And there you have it. We are done the question. Beats 98.16% of solutions, and it doesn't use much memory. This is where the memory is stored. I for the pointer, and that's about it. Otherwise, it just uses the while loops and just be O of n time, I mean, for the while loop, and then O of 1 space. So yeah, if you like that video, please give it a thumbs up, subscribe, comment below if you guys saw and like what you guys saw on the whiteboard. I'm going to be doing a lot more of that with these mediums. Hopefully over time, as you guys saw with while I was doing easies, I do get more and more proficient over time with these, so bear with me. Peace.